5, x plus 4. So the two parentheses would be x plus 5 and x plus 4. What about the inside of that? What would that equal?
X squared plus 9x plus 20.
9x plus 20. So what we're starting today, this is how we're starting every problem. You're given this expression. You are rewriting it in the factored form, which is the parentheses. Again, factors are like the two things that multiply to give you something. Well, so that's what we're figuring out. Or the parentheses that multiply to give you that expression, that polynomial. So as we go through and factor, what we're really doing is we're rewriting these expressions as two parentheses. So what you could always do, whatever I get is your answer, multiply them back together, it should be back with what you started with. Okay. Something we did, we already did the algebra tile version of it. We're going to not do algebra tile version today. We're going to go back to our area model. Something we also did before we did the algebra tiles themselves, we talked about factoring out of GCF. That is going to be a step you will always do beforehand. Because if that is a step where if you are factoring out of GCF, that is taking out something that is multiplying that problem. So we're going to see that today. If you look at this first example, is there a GCF that you can multiply or divide all of those terms by? No. No. So it doesn't happen for every problem, but if it is possible, you do it. Okay. Now for our setup. What we did with the algebra tiles themselves, we set up the x squared first. Same thing. Put it in your area model. What we also did with the tiles is we set up the ones. That's what we're also going to do here. Put that in that last box. So first term in the first box, last term in the last box. Okay. What is the coefficient for x squared?
1.
No, what is the coefficient for the x squared?
1.
Okay. So what we do, because now this is going to turn into a little bit of a process. We multiply the coefficient of x squared, so 1, times our 1s. So we multiply these two things. What do you get when you multiply those two? 5. We don't need to worry about the x squared part. We just look at 5. So we're just looking at multiply the coefficient for the x squared, multiplying with that constant. So the trick is, what numbers multiply to give you 5? 1 and 5. Are there any other numbers that multiply to give you 5? Okay, so this is considered an easy problem. You don't have a whole bunch of factors to think of. Because the trick that happens is you're looking for numbers that multiply to give you 5, but then add up to that x term, which is 6. Do these add up to 6? Yes, that means these are the two other numbers in here, which now means we have it set up where we can figure out the outside. What will be along the top and the sides? X and X, and I heard x plus 1, and what will be out here? 5. So, ta-da, our two parentheses, x plus 1, x plus 5.
Nice.
Okay. On the next part, we're going to come back to list out the steps, but I want to put the first step, because the one that you always want to think about is factor out of GCF. That's always going to be your first step if it's possible. Always, always, always. We'll come back after we do some more examples. We'll come back and fill in like our different steps. So looking at that next example, is there GCF you can factor out?
No.
No. So first term in the first box, last term in the last box. What's the coefficient of x squared? 1. So multiply these two things together. Coefficient here and that last part, which is negative 14. Good. So you are now thinking, so it turns into a little bit of a puzzle. You need numbers that multiply to give you negative 14, but they add up to your x value, which is negative 5. So what numbers in general multiply to give you 14? 1 and 14, and then we've got 2 and 7.
Oh, you can do 7 minus.
Okay, so this is where the trick is. If multiplying to give you negative 14, that means one of the numbers is going to have to be negative. Well, what would be negative if we want them to add up to be negative 5? Here, with that 7 being negative. Therefore, the two numbers we're using, the two terms we're using are 2x and negative 7x. Which then means what would have to be on the top?
Negative x and x and negative.
X and x, and then minus 7 and 2. So x minus 7 and x plus 2.
That's pretty easy.
Yes. For this, for what goes in the boxes, it doesn't matter which one goes where. So you could have put the 2 and the negative 7 in a different place. It'd be fine. Okay, we're gonna skip it, or we're gonna go to number 3. So we're just gonna pause.
Wait.
Is there GCF on number 3?
No.
Yeah, no. Wait.
No.
Since there's not, the 5 messes it up. So first term in the first box, last term in the last box, multiply those numbers, the constant times the coefficient. What do you mean multiply those two things?
20x squared.
20. Yeah, we're concerned with the number part, so 20. So you're looking for numbers that multiply to give you 20, but add up to negative 12. Okay, 2 and 10. Good. But how is it possible to multiply to be a positive number, but they have to add up to be a negative 20? If they're both negative.
Nice.
That multiplies to give you a positive 20, but adds up to negative 12, so good. So negative 2x, negative 10x. That's what goes in the box. When this one, we talked about it when we did the tiles, when it's not just an x squared, it complicates a little bit.
It can either be 4x times x.
Right. So, correct. This could either be 4x and x, or it could be 2x and 2x. So the trick is, look at your row. What could you divide both of these numbers by? So, yeah, 2x. Therefore, what has to be up here?
2.
Also 2x. Which now helps you lead to the rest. What would be in the spot?
Negative
Negative 5, and what would be at the top?
1.
What? Negative 1. Negative 1. Because the x term is negative, so that's parentheses, 2x minus 5, 2x minus 5.
Yeah.
Yes.
Doesn't matter what order you put the equation in. No.
No. Okay. We're going to keep going through. This is why I waited for the steps. After you go through some more examples, it's the same steps and process every time, so we're going to keep moving through it. On number 2, next one. Is there GCF?
Yes.
What is it? Okay. So, divide it all by 2. What's the new expression then? Okay. Now, factoring is just rewriting that expression. So, for the 2, you have to include it in your answer, but just stick it in front of the parentheses. So it's not that it just like gets to disappear. It does for solving the problem. Like now we're going to use this x squared plus 7x plus 12 to solve and like factor it. But we have to just include the 2 in front of everything. Okay. So this is our first term, x squared. This is our last term, 12. Multiply the first and the last term. What do you get? 12. So we're looking for numbers that multiply to give you 12. Okay, we got 2 and 6, 3 and 4. But what they need to multiply to be 12, but what else do they have to do? No, not 14. 7.
3 and 4.
Okay, so 3 and 4. So 3x, 4x. The x, it's just an x squared, so that makes the problem easier. This is an x and x. And then 3 and 4. So x plus 3, x plus 4. The 2 has to be in front of the whole thing. Because if you divided by something at the very beginning, it has to be included in your answer. Because if you don't, if you just put the parentheses, it's not going to multiply to give you what we started with, or what we're trying to give you. Okay. We're going to keep doing some more together. On number 4, is there a GCF?
Yes, that's it.
Yeah, it's 8, okay. So divide it all by 8. Now that 8 just goes in front of your parentheses. You don't have to do anything else with it. It just has to be included in your answer to show that we did that initially. Did that part initially. The new expression that we get to actually factor, x squared plus x
Plus 20.
minus 20. First term, x squared, last term, negative 20, first term in the first box, last term in the last box. Then multiply those together. What do you get when you multiply them? Negative 20. So you're looking for numbers that multiply to give you negative 20. Okay, so we got 2 and 10. What do they have to add up to? 1. Those aren't going to add up to 1. Or the negative 4. Okay, 4 and 5. If it's negative 20, one of them has to be negative. What would have to be negative to make it add up to be a 1? 4. Wonderful. So negative 4x and 5x.
Nice.
If it's just x squared, it makes it much easier. Got x and x, 5, negative 4. So x minus 4, x plus 5. No. Okay. We're going to keep doing a few more together. Go to the next page. Okay. Looking at number 5. Is there GCF on number 5? No. Since there is not, we're going to go straight into factoring. First term, first box. Last term, last box. Multiply the constant and coefficient. What do you get?
Negative 48.
That is negative 48. All right. So, numbers in general that multiply to give you 48.
4 and 4.
Okay, 4 and 12. We're looking for numbers that multiply to give you 48, but what else has to be true about that?
They have to equal
6
negative
and 8. They're going to have to add up to negative 2. I heard it. 6 and 8.
or 6 and
Which part would have to be negative to make it add up to negative 2?
8.
Okay. That means we've got 6x and negative 8x.
But that one has to be.
Now again, this is where it gets a little bit more complicated when you don't have just x squared. It's a 3x squared. That means one of these has to be 3x, the other has to be x. That's the only way to split 3x squared.
Three over on the left side.
Ooh, where is, so on my box, where would 3 have to go?
Left
On the top,
side.
on the top.
The left side.
Look at the row. Are both of these divisible by 3?
No, it's right side.
Also, so that means it has to go on the top. When you're factoring, you're not going to be factoring with remainders, like those aren't going to be happening. When you're factoring, you're not going to get like decimals and stuff. You're getting nice whole numbers. If you're not getting that, then that means you're either messing up on your steps, or we are going to see some scenarios that like it doesn't factor. Not today, or hold on, but that is a possibility. What would be out underneath the x? A 2, and then what would be up here?
Negative.
So your 2 parentheses, 3x minus 8, and then x plus 8. Okay. Let's look at number 8. On number 8, is there a GCF?
No.
Okay. Then that means you have to go straight into factoring. First term in the first box, last term in the last box. Then multiply the constant and coefficient. What do you get when you multiply them? 42. So, you're looking for numbers that multiply to give you 42, but what else will they have to be doing? Add 17. So just start running through it. What are some numbers that multiply to give you 42? Okay, 6 and 7.
Yeah, but you didn't yell anything.
What? 3 and 14. Oh, look at that.
Nice one, Miss Wheeler.
I didn't do it. 3 and 14. Those add up to the 17, which we need to do.
Ooh, that's.
So 3x and 14x.
I got it.
Oh, put 7.
Yeah, that's what I thought.
Nice one, Nathan.
So like, oh, I got it. Can I share?
Sure.
So what I got was x plus 7 on the left side, and then
So you put the x. Why is it 7?
because 7 times 2 is
Well, where did the 2 come from?
the upper side.
Oh, this one has like
Yeah.
that,
Mhm.
and then 7.
And then I got 3.
Good. So then what would the 2 parentheses be?
You would do x plus 7 times 2x plus
All right, let's do one more together. We're gonna do number 9 together. Number 9, is there a GCF?
Yeah, no.
Okay. Don't forget about that step. If you're not taking out a GCF, that means you're not fully factoring something. This one we can't. So first one in the first box, last one in the last box. Multiply that constant and coefficient. What do you have to multiply those? 9. So you need numbers that multiply to give you 9. But what else has to be true? What do they have to add up to? 6. Negative 6. What numbers multiply to give you 9?
1 and 9.
3 and 3, or 1 and 9? 3 and 3. If you had a negative 3 and a negative 3, does that multiply to give you a positive 9? Yes. Does it add up to a negative 6?
Yeah.
Okay. And those are our 2 numbers. Now again with that 9x squared. It's not just x squared, it's 9x squared. You can split up 9x squared by like 1 and 9, 3 and 3.
3 and 3.
Look at the row.
Oh, I got
What are those both divisible by?
3.
I got
That's
it.
how you know it's 3x and therefore this one's also.
Then everything.
And then what goes out here?
Oh,
Negative 1.
And what goes there?
Negative 1.
So what's true about the parentheses? It's the exact same thing. 3x minus 1 times 3x minus 1. The reason we're doing this one together, I don't care how you write it. You can write it like this, or you can write it as 3x minus 1 and then squared. Those say the exact same thing. It's because the parentheses are the same.
Couldn't you check your answer by multiplying?
Absolutely. 100%. Okay. I want y'all to do the other 3.